and then we have studied the recovery data analysis. Now what I am going to discuss today with you is what are the other ways to which we can calculate aquifer parameter. One is time drawdown data. So the researchers are well hydraulics experts. They have made use of distance drawdown also. They have made use of distance drawdown data for evaluation of aquifer parameter. So I'll explain to you what is the distance drawdown method. Okay, let me share. I'm audible to you?
Yes, sir.
Okay. This is just, I've shown you the field layout for conducting pumping test. Also, earlier also, we have discussed this diagram with you. So, this is an aquifer, confined aquifer, and we want to conduct here the pumping test. We want to conduct in this aquifer, which is lying below the clay, and below the clay the formation is fine sand and medium sand, and we just want to conduct a pumping test in a formation like this. And you can see that here there is also stream, so boundary is also here. So I'm not going to discuss boundary here. What I'm going to discuss is the distance drawdown, what the data we use in distance drawdown. So this is pumping well. This is pumping well, and this is a potentiometric surface here. Okay, and then what else is here? This black part is a screen part of the well, from where the water is entering into the well. Okay, now you see that here at a distance there is a well which is written number 3. It is written here number 3. So this is an observation well, and this observation well is also tapping the same aquifer as the pumping well. As the pumping well, you see that here it is a screen, so it will be showing the piezometric surface of this particular well. Then there are two other wells. One is this side. This is also an observation well. This is also an observation well. So these distances of these wells are known to us. This is 100 feet, and this one is 200 feet from the pumping well. The distances are simply measured by tap, keeping the tap at the center of this and at the center of this. This is also measured from here, which is 200 feet away. Now you see here, there is another well, which is not tapping this one, but still it is there, and it is well number 4. So what is the purpose of this well? What is the purpose of this well? Can anyone explain to me why it is here? Because we are conducting the pumping test here. We are not conducting pumping test for this. So why this particular piezometer is here? Any idea? Just think and tell. No, it's not an idea. Just think and tell.
So that may measure the fluctuation in the unconfined aquifer.
Yes, that's correct. So how it will fluctuate? That answer is correct. Very good. that it will tell you if any impact of this pumping is here. So what is the purpose? As I said that, okay, we are tapping this and we are pumping water from here. It is simple, as you said, that it is looking for any fluctuation which is taking place because of this pumping. If there is fluctuation, that means this is connected with this one. If there is any change here in water table of this particular well, then that means there is some interconnection, and this particular formation is not 100% confined, but it is acting like an acutard. So if it is an acutard, after certain time period, there will be vertical leakage, and because of that leakage, this may happen that this may also be dropping. Okay, so this is what the purpose of adding this one here. So this was not my point of discussion, but the point of discussion was, hello? हाँ वालेकुम सलाम सर, बस सब खैरियत? हाँ मैं बैठा हूँ, मैं क्लास ले रहा था, आओ. So this is so these are the wells and these are the distances what we are after. So what is your opinion that if we are pumping, so where will be the maximum drawdown? Where will be the maximum drawdown? Because of pumping, where will be the maximum drawdown? Maximum drawdown will be in the pumping well, and then the well which is next to it, then well next to it. So as the distance increases, so the drawdown will also decrease. I'll show you this also. See here, this is a scenario. This is scenario here that it is water table and we are pumping, discharging this well. So the maximum cone of depression is in the pumping well. As you move away from the pumping well, then you will have drawdown here. If you have an observation well, the drawdown will be here. As you move away from the well, the drawdown will decrease. The drawdown will decrease, and this is what this is what is used in distance drawdown method. The relationship here will be a straight line relationship. As we move away from the pumping well, there will be less and less and less drawdown, and a situation will emerge where there will be no impact of this pumping on the water table. So this is what I wanted to explain to you before going to distance drawdown method. So now I'll be coming to the main topic, distance drawdown analysis. So the simple is, just you understand here that there we are plotting the time drawdown data. Here we will be plotting the distance drawdown data, and we will not be considering the time versus drawdown data, but what we'll be considering here, we'll be considering here final drawdown because of the pumping. Suppose you have pumped the well for for 24 hours. So what was the drawdown in the last? What was the last drawdown? That is 24 hours, and what was the drawdown? 1440 minutes, what was the drawdown? That we consider for all the wells. So here we are considering distance of well and the final drawdown which is caused because of pumping in the observation wells. So we will be making use of distances between observation wells and the final drawdown which has happened because of pumping for a stipulated period. It can be 24 hours, or it can be 48 hours, or it can be whatever it is, we consider the final drawdown. So the graph which we make, that will be drawdown versus distance. The graph which we will be preparing, that will be distance versus drawdown. Okay. So this distance drawdown data can be analyzed by Thies type curve method for evaluation of aquifer parameter. Type curve used is WU versus U, that is what we have used in time drawdown data. And distance drawdown field data curve is prepared by plotting the value of drawdown recorded at same time in several observation wells at various distance. This is very important. This particular point is very, very important, that plotting of the values of drawdown recorded at the same time in several observation wells at various distances from pump well against the square of their respective distances. So this is what the data we are plotting. The methodology is almost similar. What we are changing one parameter, that is in place of time, we are plotting the distances of squares of distances of observation wells. Now this is the equation, you remember, T is equal to Q upon 2 pi S W, and S is equal to 4 TTU R square. And here the only difference what I have observed is this value is changed from 4 to, that was 4 pi, here it is 2 pi delta S. And this is well function, this is the discharge of well, and this is the final drawdown which we have selected. This is the final drawdown which we have selected. And this is S is equal to 4 TTU R square. So this is transmissivity. This T is a time which is recorded when the drawdown was recorded. Suppose it is 24 hours, so this T means 1440 minutes. And U, value of U, we read it from the graph. And the distance square, R square, is given here. Now, it is however desirable to have, what is the condition? It is however desirable to have at least 3 observation wells for evaluation of reliable aquifer parameters by use of this method. So the condition is that at least there should be 3 observation wells that should be located in the same manner with different distances. So the maximum the number of wells are there, the more reliable will be your data. We can also analyze this data by method of straight line, and in a straight line method, again what we have to do, I have just taken this. Here you have to plot the distance squares, square of distances here like 10, 100, 1000. So here, but there are only 2 wells. This is 1 and this is 2. On the basis of these 2 wells, a straight line is drawn. A straight line is drawn. And rest of the procedure will be same, that we will be measuring the time drawdown, the change in drawdown over a log cycle. We will be doing the change in drawdown over a log cycle. We'll be doing this. We'll be calculating the delta S, and here we'll be calculating R0, that is distance intercept at zero drawdown. You remember there what I have in Jacob's time drawdown method, I have talked about T0, that is time intercept at zero drawdown. That was time intercept at zero drawdown. Time intercept at, but here in place of what you call time, we are taking time distance intercept at zero drawdown. So that is R0. We have to find out that at what distance the drawdown will become zero. So for that we have to extend this line, and where it is cutting zero drawdown axis, that will be considered as time steps at zero drawdown. So the procedure is simple here again, that this is 2.3Q 4 pi delta S. This is for evaluation of transmissivity, and here this is S is equal to 2.25 TT R square 0. So this is for storage coefficient, and this is for drawdown transmissivity. So by using this particular formula, we can make use of distances, and we can calculate the transmissivity and storage coefficient. So again, it is what this method is, just it provides an independent check on the time drawdown data analysis that it should coincide. I mean, all the data transmissivity and storage coefficient which we evaluate by time drawdown data, it should be similar or very close to this calculation. So it will be providing a check whether the data which we have analyzed is correct or incorrect. So this was the last topic of your unit 1, and I have asked Dr. Isra to talk to discuss Bolton's method with you, and in meantime, tomorrow I'll start the second unit, and there I'll be talking with you regarding the what you call this image well theory and determination of distance of boundaries from the pumping well, and impact of boundary, at what time boundary affects the time drawdown data. This I will discuss tomorrow. I planned for it today, but I have a guest, so I'll stop here. Okay. So if you have any question related to this, you may ask. So tomorrow when you are free, you just tell me. I will be talking about the boundary, evaluation of aquifer boundary, and what evaluation, that where the boundary is located, whether it is a positive boundary or it is negative boundary. So we can, if it is a hidden boundary like some impermeable formation, and it is not exposed on the surface and it is affecting time drawdown curve, so we can know that at what distance, like dikes and some other thing is there in that area that act as a barrier. So that distance we can find out that at what distance the boundary is located from the pumping well. So this we'll discuss tomorrow, and we'll be discussing the theory of images also tomorrow. All right.